Yeah, so thanks so much. Again, my name is Edward Thomson. I am a program manager at Microsoft, where I work on the Git community for Visual Studio and Visual Studio Team Services. And yeah, I actually used to be a dev. I'm a program manager now, which means I don't actually write code anymore. I used to actually write version control code. Now the closest thing I have to an IDE is either Outlook or maybe PowerPoint. One of my coworkers tried to console me by pointing me to some YouTube video that shows that PowerPoint is actually Turing complete. This didn't actually make me feel better. It really just terrified me. If you want to be similarly terrified, I would encourage you to check it out. But I am still a developer at heart, so when I leave work and put Outlook and PowerPoint behind me, I'm one of the maintainers of the libgit2 project. If you're not familiar with libgit2, it's a linkable library that you can use in your application to do management of your Git repository. So if you're building a Git GUI or an IDE and you want Git integration, it makes a ton of sense. But even if you're writing a simple app that does some work in a Git repository, maybe it looks at what's going on and tries to validate things, who knows? It's a lot easier in many ways than talking to Git on the command line. If you want to run Git status, then you've got to kind of screen scrape the output, or maybe you're going to use some regular expressions, and as they say, now you've got two problems. libgit2 was developed at its very beginning from Git itself. So the Git program is a mix of C and Perl and Python and all sorts of things. And we took, in libgit2, a lot of the C code out of Git to bring into libgit2. We want it to be perfectly compatible with the Git project. So libgit2 is written in C. Much of Git is written in C. I love writing C. C is a great tool to use to build an application. It's really powerful, right? If you want to write a device driver, if you want to talk to the kernel, you're probably going to do it in the C language. And if you want to, say, make some syscalls in another language, like Ruby or Perl or Python, whatever, you're probably going to make use of the foreign function interface or the native code. In C# it's p-invoke, in Java it's JNI, to talk to C, because it's that powerful. It's also really fast. The reason it's fast is because it doesn't do things like error checking on inputs. So if you have, a 5 megabyte buffer and a 10 megabyte file, C isn't going to complain. It might crash. It might not. It's actually undefined what happens. It might just be a giant security hole. Which brings me to number 3. It's secure. Oh no, oh no. C isn't actually all that secure, which is a little bit terrifying at times when you're building a version control system on top of it. And in fact, a really popular version control system. Now, there are lies, there are damn lies, and there are statistics. These particular statistics come from Stack Overflow. Their most recent annual developer survey shows that something like 70–80% of developers are using Git. Maybe not exclusively Git, maybe they're using another version control system as well, but almost everybody is using Git. The next runners-up are Subversion and Team Foundation version control, and they barely clock 10%. That's incredible. Everybody is using Git these days. It runs the American stock market. NASDAQ uses it. It runs the operating systems that we put in our pockets. Android and Apple are both using Git. I now realize that NASA's actually up here twice, but you know what? If you put rockets in space, I think you get double billing. But they're using Git, and I want the rockets to go up and not come back down. So it's very important that we take security seriously in the Git projects. Sort of the nightmare scenario for me, at least, is that we might have some security hole in Git that allows remote code execution on a developer's machine, or lets somebody get put files into a repository without anybody having to know it. That actually kind of keeps me up at night. And it's especially important for the libgit2 project. I mean, of course it's important for Git, but it's also important for libgit2, because you may not have heard of libgit2, but we've actually heard of you. Turns out we have some pretty high-profile users, probably where you host your code. GitHub uses it, Visual Studio Team Services uses it, GitLab uses it to merge your pull requests. So libgit2 is actually responsible for putting code into your repository. So yeah, and I wrote that code. So really, I do actually take this very seriously. I think about this quite a lot. Bitbucket doesn't actually use us to complete pull requests. I'm going to have a conversation. I want to fix that, hopefully this week. But because everybody who hosts Git repositories, at least at scale, uses libgit2, it's very important for us to take security seriously, right? The interesting thing, though, is that I mentioned C. What we don't super see a lot of in Git and libgit2 are the sort of things that you might traditionally think of as problems in C, like buffer overflows or integer overflows. They of course exist, but we do a really good job of code reviews on the code coming into the Git project and into the libgit2 project. And we look for these sorts of things, and of course we find them, and we reject code reviews. We edit code until it passes. But even throwing the best computer scientists and software developers at this sort of problem, like Jeff King, who handles a lot of these issues in the Git project, isn't enough. Because the best computer scientists, the best software engineers are still computer scientists and software engineers, and we're still human, and we make mistakes. So, of course, we use a number of static code analysis and security checking tools to help us with that. And these find problems too. In libgit2, we've started looking at using fuzzing to help us even further. But really, like I said, the biggest problems aren't these. The biggest problems are assumptions that we make. Can I see a show of hands real quick? Who's using Git? I expect everybody. Now keep your hand up if you're using Git on Mac or on Windows. Put your hand down if you only ever touch a Linux machine or an S39. Now look around and see who's got their hands up, right? OK, thank you. You can put them down. So this actually matches up with yet another survey. Sorry to keep throwing numbers at you. This is why I'm a program manager now. Windows, this is desktop usage for developers. And we see that Windows is the predominant platform for developers. Mac is number 2, and Linux actually shows up. That's why you know this is a survey of developers. But Windows and Mac are still the predominant systems, right? And that actually is a little bit at odds with the community building Git itself. If you know the history of Git, you'll know that Linus Torvalds invented Git to help him build the Linux kernel. So it's no surprise that a lot of the Git developers themselves use Linux. And that can lead to some interesting problems when you're not actually part of your core audience. And so I want to talk a little bit about a security vulnerability that was perhaps introduced maybe because of some expectations that were violated because of that. This, as you can tell by the name, is not a sexy security vulnerability. It doesn't have a name like shell shock or memcached. It's just got an incident number from MITRE, the clearinghouse for security vulnerabilities. It's called CVE 2014-9390. And that doesn't sound like a lot to you, but every time I hear it, it still shivers up my spine. Let's take a look. So I've got a repository here. It's a really simple repository. It's just got a file in it. But as the name implies, there might be something a little weird about this particular repository. Okay? So what's actually in a Git repository? I've just got this one file up here called hello.txt, and I've got this folder called .git. And you may have never looked in this folder called .git. If you're on Windows, it's actually hidden, so you may have never even noticed that this exists. But this is the .git folder. This is your Git repository. We talk a lot about how Git is a distributed version control system and how everybody's got a copy of the repository. Well, that's where it is, in .git. Now, what's actually in here? Well, we've got a couple of things. First of all, we've got our branches are stored in the .git folder. This is information about the branches that we have. I only have one right now on my local repository, and that's called master. But more interestingly, I've also got this folder called .git objects. And you see some hex numbers, some 2-character hex numbers. So these are folders, and if I look inside one of them, I see some files. And so what's actually going on, this is an actual Git object. You're probably used to seeing 40 characters of hex as a Git object, whether that's a commit or a Git tree, or Git also stores files in here as objects. They're called blobs, and they're stored with the 40-character hex ID also. So if you've never gone looking around in your .git folder, this stuff is kind of interesting. And it's kind of important. That's why Git hides it from you by default. Okay? So let's actually check out a different branch. I've switched to a branch called hello repo, and nothing really seems out of the ordinary so far. I've still got a file. It's called hello.txt. Great. Let's look again in our .git folder. Now, I've actually got a file in here that I didn't have before. It's called hello repo.txt. Now, that's not quite right? If you run git status in your repository, you don't see the stuff in .git. It's all hidden from you. Git knows to not worry about that. Git actually doesn't let you touch it. You can't get add files in there. You can't get RM files from there. Git protects that from you, because it's its space. That's your repository, and only it can touch it. Well, or so we thought. We've actually got a file in here. Let's take a look at it. Let's make sure it's not actually something that Git managed. No, oh no. That doesn't look right. That doesn't look like something that Git would do at all, right? Right. So what happened here? Let's take a look at our head commit. Oh. Well, we've got this funny tree here called .git, and if you notice, it's in all uppercase. Oh, what's in that tree? Well, let's inspect what's in that folder there, and oh yeah, it's our file, hello repo.txt. So what's actually happened is we've added a file to Git called .git, all uppercase, hello repo.txt. And so what Git has done is it's tried to open that file, .git, hello repo.txt, and it's happily written that into our .git folder. That's why I asked who's running on Windows, who's running on a Mac. The thing that those two systems have in common is that they both use case-insensitive file systems by default. So when I open .git, it gives me the Git directory, lowercase git. And Git is smart enough, at least this version of Git, to know not to allow any users to add files in lowercase git, but it's not smart enough for uppercase git. So that's interesting. So we've got a file in our .git repository that we didn't expect to have, but can we actually do something with that as an attacker? Well, let's take a look at one of our other branches. Okay, so, right. So I'm going to go back to my master branch, and then from there, let's take a look at this hello.txt. Okay, hello world. No big deal. Now, let's check out a slightly more evil branch called replacement object. Oh, well, okay. It's pretty clear that we're trying to do something a little bit sneaky here, right? We've got this crazy error message, and at best it doesn't make sense. At worst, you're like, alarm bells are going off. But if you're in the category where this doesn't make sense, and there are a lot of people who are getting started with development, who are getting started with version control, and they might read this and have literally no idea what it means. And they might ask a friend, they might go to Stack Overflow, and especially if you're going the Stack Overflow route, you might copy and paste this error message, but you might want to be secure about it. You might think that your file names are really important, and leaking that information on Stack Overflow would be bad. So you change it. So now on Stack Overflow, you've asked a question like, well, the following untracked working tree files would be overwritten by checkout, filename.txt, right? That's a totally reasonable thing for somebody to do, and I understand why they would do it. And if they were asking that question, they might get advice, like, well, here's how to get around that. You can, why don't we switch to the replacement object branch, we'll create a new branch locally, and then we'll git reset to the origin. There we go. Well, now we've checked out that branch that we really wanted to check out. Maybe we wanted to code review it. Who knows? And what has happened? Well, I've deleted my hello.txt locally. OK. But let's actually take a look at what came in head. Oh, it's another .git directory in all caps. OK. And what's in that .git directory? Well, a directory called objects. And inside objects is AF, 2 hex characters. And inside the AF directory is, well, that's a Git object. So we've actually checked out a branch that has now written a Git object into our Git directory. And I didn't show you earlier, but that object ID happens to be hello.txt in our master branch. So now what we might do is do something clever, like, well, I want that hello.txt back. So I'll git merge master, right? That's the logical thing to do. Oh, there it is. What's actually in that file now? Oh. Ouch. We've actually taken advantage of another wrinkle in Git, which is that it doesn't actually validate the hashes on every operation, because that would be just punishingly expensive. When Linus started looking at version control systems, he looked at a tool called Monotone. Monotone was in many ways the ideas behind Git. It used a Merkle DAG for storage, it used SHA-1, and it validated the SHA-1 checksum. It did a hash on every operation. So it was insanely slow, especially at the Linux kernel scale. And so by default, Git doesn't do that. And so if we can somehow convince Git to write a new object into the .git directory, well, we can take advantage of that. Now, this is a pretty questionable attack, right? But when we switch back to master and look at the file, it's still there. So we've totally poisoned the Git directory. But yeah, not super obvious. First of all, you've got to convince somebody to check out this branch that you've given them. And then you've got to convince them to ignore the error message and somehow run a series of commands that they probably don't understand. So it's not a great attack, right? It's a social engineering attack at best. And frankly, there are probably easier social engineering attacks that don't require people to use Stack Overflow to get there. Okay? So what else could we do if we're being inventive with this problem? Well, let's take a look at this branch. It's a branch called hooks. Okay. And what I'm going to do is I'm going to create a new file and add it to my index and commit it. Oh. Well, that's not expected. Huh. So what's going on here? Well, let's take a look. Okay? Let's clear that. And let's look at this branch that we just merged. Aha. So what we've now done is we've added a pre-commit hook to Git. Most people don't actually have hooks in their .git directory. A hook will let you basically run your own script at some point in time in the Git execution flow. In this case, right before Git does a commit. So when you run git commit, Git will look for a .git/hooks/pre-commit file, and if it's there, it'll execute it. And so if an attacker has figured out a way to put one there, it will execute it. And in this case, this is very innocuous. It's just running some Apple script to pop up an OK dialog, but it could be a Bitcoin miner. It could be rm-rf. It could be send your email to boss telling him that you quit. It could be any number of things. So this is not super ideal either. Now, again, you've got to figure out how to get this in somebody's repository. If you sent a pull request with a random pre-commit hook that all of a sudden started executing random things, it would probably not get accepted and merged. But you could, in fact, convince somebody, hey, I've got this really cool repository, why don't you clone it from GitHub and maybe get access to their machine. Again, social engineering attack, there's still probably better social engineering attacks, but this was really incredibly serious when we discovered this. And of course, I didn't discover it. I say we, I mean the greater community. In fact, it wasn't the Git community at all that found this. This was originally found by or reported to Mercurial. Mercurial actually has the same or a similar problem. They don't have a .git directory, they have a .hg directory, and they made the same assumption about case sensitivity. You can't write into .hg with Mercurial, but you could with all caps. And the Mercurial team was kind enough to disclose it to the Git team. The Git team was kind enough to disclose it to the libgit2 team. And we're really glad that they did, because when we heard about this, we were like, oh yeah, that's important. Also, it's not just case sensitivity. There are a bunch of ways that you can abuse Git to write files on Windows. Anybody remember? This is a young crowd. You guys all look so fresh-faced. Does anybody remember DOS and its 8.3 file names? And at some point, we added the support in Windows for longer paths. And there were various translations that you could do that involved like tilde1 and tilde2. You can use that system from the DOS to Windows era to get paths into the .git directory. On Mac OS, there are various Unicode characters that aren't printable and thus can't go into file names and are just kind of completely removed. So if you throw one of those into the middle of .git, you can attack it that way. So this was a really big deal for us at the time. In fact, this was perhaps the first major security release that came to Git. And I'm actually really proud of the way the community handled it. We were able to build joint releases. We were able to work together to fix this, both with Mercurial and with the Git community overall. So we saw simultaneous releases of Mercurial, of Git for Windows, and libgit2, all fixing the problem at the same time. As far as Git hosting providers went, since some of the core team on Git work at GitHub, they were able to patch their servers, and since some of the libgit2 core team work at Microsoft, we were able to patch ours. So the same time we announced that we had fixed this security issue in Git, and you should go download a new Git, we were also able to announce that if you tried to Git push an evil repository like this on GitHub or on Visual Studio Team Services, that we would block you from doing so. So we couldn't be used as an attack vector to propagate these sort of security vulnerabilities. GitHub actually scanned every repository they had looking for anybody who had tried to do this and did not find any, which I think is actually really cool, because as Carlos just mentioned, they got a lot of repositories. So we were pretty confident that this security vulnerability had actually never been exploited. And finally, we did simultaneous releases of Git clients. We updated GitHub Desktop and Visual Studio. Visual Studio's support matrix is quite deep, so we actually had to update many, many versions of Visual Studio. So I'm really proud that we were able to come together and make all this happen at the same time. But if you're astute, you'll notice that there's, a lot of logos on that slide, but there's a lot of logos missing as well. And that was perhaps the biggest takeaway that we had. Although we were able to work together and build simultaneous releases for a lot of products, we really weren't helping the community as much as we could have. We could do better here. Because where's Atlassian on this release? Source tree should have been notified, and I honestly don't remember if they were or not, and I feel really bad about that. That's not the way to build a community. Obviously we all kind of compete with each other on one level, but using security bugs is not a competitive advantage, right? So the biggest thing I think that fell out of this security issue, CVE 2014-9390, was that we now have a Git security group. And it's made up of vendors, it's made up of Git contributors, and contributors to other projects that aren't just Git, like libgit2, like JGit, so that we can share knowledge. And again, security issues aren't a competitive advantage. We need to work together and collaborate to fix these problems. So there have been a couple of other security issues in Git since then, and we've used this group to collaborate to great effect. Don't have time to talk about all of them today, so I made a little quick link. If you want to learn a little bit more, aka.ms/git-security. I encourage you to check that out. So that's all I've got. I just wanted to say thanks for listening, and thanks for letting me help keep your Git repository secure.